is lesson 100 in your Simple Solutions book? I have 4 to go over again, so short video, you'll be fine. We're going to start with number 3, and number 3 was kind of wild, so stick with me here. It says, a standard refrigerated container has a capacity of 1,000 cubic feet. I'm going to write that down because it sounds important. Okay. How many rectangular boxes can be stored in the container if each box is 4 feet by 3 feet by 2 feet? So let me just draw a box real quick. It's not going to be a perfect box, but it'll do for now. Okay, and these boxes are 4 feet by 3 feet by 2 feet. And I want to know how many of these boxes fit in a storage container that's this big. Now, it's easy to do once you know the volume of this box. So let's find the volume of this tiny box. Remember, the volume of a rectangular prism is your length times your width times your height. All right, so I have the volume of this tiny box is 4 times 3 times 2. 4 times 3 is 12, times 2 is 24. Okay, so this little box is 24 cubic feet. Okay, now it becomes a division problem. You're asking how many times can this number fit into this number? So let's set up our division problem. I have 1,000 divided by 24. Okay, 24 does not go into 10, 24 goes into 100, 4 times. 4 times 4 is 16. 4 times 2 is 8, plus your 1 would give you 9. You gotta borrow across here. You got a 4 down here. Drop your 0. How many times does 24 go into 40? Well, 24 times 2 is 48, so it can only fit one time. You have 24 here. So I have 41 with a remainder of 16. Now, I can't do anything with this remainder 16 because it didn't ask how many partial boxes can fit in the storage container. It asked how many full boxes can fit. So my answer is only this 41 can fit in the storage container, and then I'll have a little bit of space around those boxes. Okay, so your answer there is 41. I know that was a lot of thinking and a lot of math. Moving on to number 7. Number 7. Is there a type of rhombus that is not a parallelogram? If so, draw one. No. All rhombuses are going to be parallelograms, simply because they have all of the same length sides. I'm going to draw a couple. They're not going to be perfect. Rhombus, also a parallelogram. Rhombus, also a parallelogram. We'll do rhombus, also a parallelogram. You will be incapable of drawing a rhombus, which is a 4-sided shape with all the same length sides, that is not also a parallelogram. So all rhombuses are parallelograms. That's number 7. Number 8 says solve 25 and 2/10 divided by 10 to the first. So it says 25 and 2/10 divided by 10 to the first power. We've done a ton of these in class together. It's just been a while since we've talked about them, so I wanted to kind of refresh our memories. Remember when we have 10 to a power, we're just going to move this decimal place, the number that our power is. So our power is 1 this time, so we're going to move our decimal place 1 time. The question you have to ask yourself is, do I move it this direction or do I move it this direction? To answer that question, you have to think a little bit about what you're doing. It's asking you to divide, which means your answer should be smaller than the number you start with. If I move my decimal place this direction, I get a bigger number. That number turns from 25 to 252. So that would be the wrong way to go. I would like to move my decimal point, oh, I erased it. I need to move my decimal point this way, and then my answer would be 2 and 52 hundredths, which is definitely less than 25 and 2 tenths. All right, so just a refresher on that one. I know we've done them a ton of times. All right, last but not least, number 12. Number 12 says 12 loads of sand were separated equally to fill 5 sandboxes. How many loads of sand went into each sandbox? All right, we've also done a ton of these together in class, but I figured it was about time for a reminder. This is one of those something shared by someone else, right? So first we have to ask what is being shared. And the loads of sand are the things that are being shared. How many loads of sand do we have? We have 12. So 12 goes up here in my numerator. Shared by, what is doing the sharing? Well, the sand is being shared by sandboxes, so it's not a who, it's a what this time. And how many sandboxes do we have? We have 5. So 12/5 of a load of sand goes to each sandbox. Now, we know that we're not going to keep this as an improper fraction, right? Good. So 12/5 as a mixed number. How many times does 5 go into 12? 2 times. What's my remainder? 2. Keep the same denominator. So I'm going to have 2 and 2/5. And it is a word problem, so it needs a label. 2 and 2/5 loads of sand go in each sandbox. All right, that I feel like was a pretty easy lesson, but let me know if you have any other questions. Bye.